How's it going, everyone? Welcome, Egulier, again, looking at the React Performance, a course taught by Steve Keeney, head front-end engineer at Temporal. This open source execution durable platforms that behave somewhat similar to Kubernetes, but to cover specific business use cases. So for example, Virtual is using that tool. And the goal of today's video is to briefly describe the goal of this course, as well as this video, the core structures, and how that lead us is to understand is the React dev as a way to make sense of how do we get here. And by briefly describing is the learn section here, describing the UI, adding interactivity and managing state, how now we can connect all React components to external systems. So today's video will focus on synchronizing effects, and you might not need an effect, as well as the life cycles of reactive effects. And for that, I'm going to make a quick recap, as I mentioned before, about this course. Well, the goal of this course is to learn how to write this performant React components, therefore performant React. And for that, we need to look at this introduction as a way to, well, if you want to optimize something, you need to first understand how that things work very, very, very well. So that's why, for example, in the case of performance, in the context of React, it is way much faster to not doing stuff than doing it. And there's some corollaries to that, which is it is much more faster doing stuff later than doing it today, right now. So because of that, we need to actually understand is how React works, to develop some tool set as a way to, anytime we encounter this performance issue, we can come out with some solutions, aka best practice, as a way to now solve them. Pretty much like having a big knot, and you have, when you pull the right thread and you apply the technique that you already know over and over and over, you actually demystify that, solve that. So, and because of that, we need to look at, well, how this React rendering works. And one of the great things of this React 18 version is that now they build this for self-learning or self-taught developers that can go through these sections and have and develop a sense and intuitions, as well as improve their technical communication, and how now all of the things fall into pieces, joins together. So by looking now at what React framework is, which is a JavaScript framework that allows to describe UIs using JavaScript functions, and we also look at how can we import those components, export them, as well as using these GSX syntax as a way to connect the JavaScript world with the HTML using the curly braces, and how can we render conditional components, lists of components, how also can we pass down or can we receive props or pass data to these components through props, and how important from the React perspective is to write these components in a pure way, and why it matters. Because at the end of the day, building these components in the pure way, pretty much like the functional way, or like writing a function, you given the same input, you always get the same output, all right? So for that, we look now at the reason behind that, which is, well, it allows now these components to be run on any JavaScript environments. So for example, on the server, So if you provide some data to these components, you will make sure that you always return is that component to multiple users. Another thing is we can now catch these components, therefore we can prevent computational, we can avoid is computational time by using memorization techniques or this catching mechanism built in React, for example, like memo or callback. And also, when it comes to actually pass down data to a render tree, how can we safely stop the executions and rerun it or re-rendering that again? So when we talk about this render tree, which is the way of how now React sees these components, it also is interesting because this is a concept for computer science as a way to how can we organize data, okay? And you can think of this pretty much like having a cabin, a fridge, or a backpack where you put stuff in there. And each one of those actually allow you to do or allow you to store things, specific things, you know? They help you to store or access specific stuff, which means that in your fridge you can put is ice cream and fish, in your backpack is your iPhone and tablet, keyboard, mouse, in your drawer you can put all of your pennies. And if you like purple things, you can put also your some sexy stuff as well. You can put that also in the fridge, and your fish on the backpack, but again, you're gonna get a very smelly backpack if you use that regularly for that. The idea here is that with this kind of example is now we're able is to look at this analogy, real life analogy with this abstract concept, which make it meaningful not only for myself but also for those who wants to learn that and how to develop a sense of what these tools allows or these concepts allow to do is for that. So in the computer science we have now is array, hash, linked list, double linked list, stacks, queues, trees, and graph. So now with trees, data structure here is the way how now React actually organize all of your React components as well as the tree dependencies, which means that all of this necessary code that provide this functionality to these components and interactivity to these components, which is now the next stuff as you're going to write your React components, adding interactivity. So it means that if you don't do that, if you don't add interactivity, you're just writing is plain HTML. Okay, so because we are now working, because we want this to build is this dynamic UI representations and actually show something to the user, we look at how can we now using event handlers as a way to now provide or add in this interactivity by passing a functions to the event handler using the curly braces with the GSX, okay? And then because most of the time we want is to show data to the user. So for example, if you have your bank account, you have now is, well, the balance and the transaction history and that kind of thing. So how now that lead us, okay, is to find a way of how we can show data. And that is the state, a component's memory. We also look at how can we pass this state, how can we now develop, how can we now use this state using this particular hook tool that React provide, use a state, and how can by setting up our state into a new state, aka updating our states, React passed through a rendering mechanism that instead of us having to manipulate the DOM or the attributes or the event listener, React API allows in a descriptive way to abstract that while he's being able to do that DOMs updates for us. So this rendering mechanism, which is made of 3 phases, the trigger, the render, and the commit. First, on the trigger, it say, hey, you know what? When this state update change, what will happen? It was at the initial render, or it was caused by a component or any of its components whose state updates. So once you detect that, now it's time to render that, which is just a fancy name to say we are just calling your React components, aka your functions. So if this happening, this state update happen at the root element, okay, well, we are going to now create the elements for that, okay, using the create elements method from React. If it was caused by a re-rendering, it means by a component that state updates, React will call that component that trigger that state updates. It's going to compute all of its props, states, event handler, store that information to be later used in the next phase, and then the output of that function, if that contains React components, it will call them, and if that component contains more components, it will call them in a recursive way until there is no more React components. So when that happens, now on the commit phase, okay, is when this happened, when the state update happened, if this was at the root element, if you remember the tree render, if this was caused at the root element, then React will going to append all of that element using the append API based on the elements I create in the previous step in the rendering, and append that all of the elements so you can show that. That's quite brilliant, and that's quite interesting, beautiful as well. That's design. And also, for example, if this was caused by a re-render in the commit phase, okay, so it will now, because it recreates in the rendering phase this concept or this thing called the virtual DOM, which is just a representation of the ideal UI state kept in memory and sync with the real DOM. So this is a programming concept, this VDOM, as a way to represent is the ideal, as I mentioned, represent is the ideal UI element of the UI in memory, in RAM, and then keep in sync with the DOM. So this is something interesting because once React actually recreate that, okay, and then because it holds is a previous version of the VDOM, and when we recreate that, when we re-render the components, by recreating that in the commit phase, it's going to apply now the reconciliation phase, which is what I described, this process of how now React have this representation of the virtual DOM in memory and they keep in sync with the real DOM. So this is what allowed for us to, this is what allowed for React developers to interact with that API in a declarative way, so we don't have to manually, as I mentioned before, to set the attributes or the event handlers or manipulating the DOM manually So we just only tell React what state we want our UI to be, and make sure that make sure that the DOM match that state. And I think that's quite beautiful, but this design is quite powerful as well. And because now, when it recreates the virtual DOM, it has some additional information that it passed to, or as they call fibers. And the fiber is this reconciliation engines that it was set up at React 16, and now it allows us to do a couple of things. So prioritize rendering prioritizations. Rendering prioritizations. The concurring rendering, as well as the ability to pause, resume, and stop a rendering. And I mentioned that because this is what happened when on the commit phase, in this reconciliations phase, okay, or during the commit phase, is going to apply only the necessary DOM updates to the DOM. And then the browser detects those changes and repaint your screen. And this is a mechanical, beautiful design process that happens over and over and over and over and over, and you get the idea. And I think that's quite beautiful because now it has strapped, but of course offers some challenge when it comes to describe of our UI as a state. So we also look at how can we setting our states inside of an event handlers, and by setting the state, we're going to get the value in the next render. And inside of your event handler, when you're setting your state, you can think that React fixed that state for you, aka this is a snapshot. So states act as a snapshot for every render. So then I look at how you can now, for example, work with the previous states as series of states update, or queuing a series of state updates, okay, as a way to work with the previous state. And this is something useful when it comes to work with async operations. So far so good. That's great, because now I also look at how can we update object in a state, array in a state. The TLDR is that always return the new states. For objects, you can use the spread operator, and for array, you can also use the spread operator, or map if you want to apply some transformations, or filter if you want to remove one element from that, or how do you put it? Exactly. Exactly. Or inserting element in a specific position as well. And then, because we are now representing our UI and adding interactivity as UI state or as state, it is important to, when it comes to actually build more and more UIs, learn how to think UI state or UI change as a state change, as a way to now dealing with the complexity of handling all of these different components with all of these different states. So the idea here is that, which is something that React provide you, is that thinking in React is by saying, hey, it is important when you're going to write your components, use the same concept for the UI designers, or this concept from the UI designer, which is the mockups. So identify all the different visual states, then determine what trigger those state updates. So for example, with the state machines, which is a concept from computer science, this is when design and the computer science joins together, then determine what states or determine or represent those states that trigger the state update, avoid any non-essential states, and then connect the event handlers to set that states. So this is now this particular mindset when you're going to write your UI and detect those state change. And when it comes now to actually manage your state, or specifically how you can organize your state, here they borrow a concept from the database engineer called as serialization, that is normalization, sorry, where it say, hey, eliminate any redundance and eliminate any redundance or duplicate data. So in this particular case, when you structure your state, you say, hey, let me is group states related. So group related state in your code. Avoid any contradictory states, avoid any redundant state. If you can get that data from its prop states, do that. Avoid any duplicate states, because that make it hard to keep sync, okay? As well as avoid deeply nested object in your state. And deeply nested object is an incorrect term, because at the end of the day, when you define is this object instead of an object, they just only point is that object into the properties that has a reference. So, but again, the idea here is that avoid to do that because it make hard to update those kind of objects. And it is in terms of now thinking in React, okay? You need to have the mock, you need to have the data, then you're going to figuring out how you're going to break down your UI into components, and then represent the minimal but complete, define as a static version of that structure with static data, and then represent the minimal but complete UI state that it can be, and therefore identify, which is something that is here, and therefore identify where this state should live. And that is the next topic that we want to talk, which is how you can now share components across different it's like how you can share components across different how you can share states, across different components. And that's quite interesting as a way to, well, it's going to apply this inverse data flow direction, or AKA when you define your components, each piece of stakes, you will choose which components owns it. And by doing that, you're making now that component and those children components that use that capable of consume that from the source of truth. And also when you're going to write your components, how helpful is to think in terms of these components, the information that it's going to handle, it is based on its props. And if it is, they call this as uncontrolled, controlled component, which are flexible components. Or if this data that you're going to manage is represented using an state, so this is called now as uncontrolled component, or the configuration components as well, most of the time. So now that we look at how can we actually share that state across different components, okay, and using this data inversion flow as a way to now on the child component is when you're going to trigger. You define is your state on the parent components, and the child components you now hard code them to actually accept the props or the event handler that you need to, and then you connect that with the state as a way to update the state like that. So as a way to update the state at those child components and receive is the state if that component needs to. A good example of this is when you're creating your product product filtering. So you have now the search bar followed by the product list, and how you create now a wrapper around this component or this pattern component that's going to be able to share that state across the search when the user typing, and now filtering that list based on that user input. And because at the end of the day, if you want to reset your components or reset the state of your components, and this is something that the way how React see your states, okay, which is at each the component in React. So states are in React. State identify is each one of these components. Wait, what? Yeah, in React, each state is associated to a each state is associated to a position in the render tree. Okay, so by default, all of this, if you have the same component at the same position, it will preserve that state. If you have different components at the same position, it will reset that state. But if you want to reset the state of the same components at the same position, well, you can use or make that components to be rendered in a different level of the render tree, or add a key for that, which is putting a label to this and indicate React, hey, this element is unique, so I want you to now keep track of this. Pretty much like having a folder with all of these files and you know what's going on there. And because as our state needs to react to more inputs, no pun intended, here it makes much more sense to use a maintainable way to keep our state update maintainable. So that's why now React team come out with this thing called Reducer, which is not a thing from them, it's actually from the functional programming. But this Reducer, which is just a function that takes a state and an action and an option and an option type and an action object to generate a new bit of a state from that. So the whole point of this is that by you have this centralized place to keep all of your state updates logic in one single file or in one place, you can now have much more certainty as a way to what's going on and which states this, in which inputs this state can be or can react to. Inputs, whether it's computer inputs or human inputs. Human inputs is like navigating to a URL or clicking, scrolling, or computer inputs like receiving data from a server or waiting an image to be loaded on the browser. So with that, we look at how can we do that using the specific React hook called Reducer, and you pass is the reducer function and the first parameter, and then the second parameter is the initial state. And then you can now is when you need to update the state, you're going to dispatch is a object that contains that action that must be registered in your reduce function. So now you have much more is predictability when it comes to do that, aka make it easy to maintain your application. So on that topic, and how when it comes to actually pass down data to distinct components, because so far we have looked at the way of how we can pass data is through props, okay? And because if one of those elements along the chains disappear or remove from the DOM, you break the chain. So to prevent these props drilling issues, contexts say, hey, I'm gonna be a centralized place when I'm going to now is pass you data or this state to all, or this context to all of this child component that it needs to, right? So the way of how you can do that is by creating your context and then use that context, the component needed, using the use context, and then provide that context at least one level up the component that is consuming that. So this what allows is to make aware of the surroundings. So the sub-tree components is now aware of its surrounding of data. So one of the use case for this, or several cases of using this, is when you want to pass small data to that, all right? For example, themes or analytics, authorizations. Also, for example, the React router actually using behind the scenes is this. So React router behind the scenes is actually using that. Which is creating a context as a way to keep track is at which URL position is this. Yeah, it's a way to keep track at which position is right now the user, right? The URL, at which URL the user is currently at. Jesus. And then also when it becomes very useful for now managing your state and scale that up. Something that we're going to talk about that later. But before that, we need to also to understand that using context, it can be tempting to use anywhere. Please avoid that. Why is that? Because before using context, evaluate that you can pass down data, evaluate that you can pass down that data through props, or to extract that component into a GSX and then pass the proper data. Because one of the caveats of using context is that it will render, so React will re-render all of its child component that use that specific context starting from the provider, that data or that value change. So that might not be something that you want. And to prevent this kind of behavior, so when that value changes or when re-render that component, especially when the value changes on the provider, you can use it, for example, optimization techniques like useMemo as a way to catch this computation between re-renders and only trigger when any of this dependency change. It's similar for the use callback. I want you to catch this function between re-render and only apply that when any of its dependency change. So That's quite interesting because that lead us is to how you can scale now with reducer and context, and which is a in the this is a technique, or this is now how you're going to write your applications and how you actually look a lot of applications using, for example, authentication or small piece of data that is going to store in the context. So theming, analytics, or authentication, you know, and how in there by using reducer and context, it makes much more easy to deal with. How so? By creating your context with the state, another context with the dispatch, and then in dispatch, which is part of the reducer function that you're going to write in that file, okay, and describe what is the type of action that you want to update this state, and then you're going to now write your function that is going to define the use reducer as well as provide the context with the state as well as the dispatch or the state updater. So that's quite interesting. As well as you're going to pass is the children that you receive as props. And that's quite powerful because now you can have much more fine control about which state this UI can be. And this is all about with React, okay? So hey, I'm going to tell you which I'm going to tell you to React which state I want you to be this UI so you can match with the DOM. Yeah, that's an interesting idea. It's a very, very interesting idea. So, but in any case, because at the end of the day, we are not only writing our applications to only show UI elements or to show different UI state or react to different inputs. We also need to connect that to external systems to keep sync with them or to control external systems. That's why we look at these escape hatches, which is the way of how now React allows you to, well, control and sync with external systems. So for example, you want to focus an input using the browser API, or you want to now connect to a video tag or a widget that is not built in React, or to connect and listen to events or listen to a message from a server. So here we can look at how now we can actually do that, and first see how you can remember things without trigger re-renderings, okay? And how you can remember things between re-rendering using the useRef, and how useRef is this secret pockets that has an object on the current where you can now store things like a timeout ID. Again, this is the most common use case. And if you stick to that, you will not find any problem along your way. So like timeout ID, or the storing objects, storing the reference of DOM objects, or storing objects that are not necessary during GSX rendering. We also look at how can we use a ref as a way to, when we click a button, when we respond to a button, how can we now store the reference of our timeout ID as a way to start as a counter, okay, or time left. So with that, okay, I also look at how you can how you can manipulate its DOM elements using the useRef, okay, and the question is that now how this useRef fits into the rendering mechanism. Okay, so useRef, it's first it is initialized after the before the commit phase, and then set up after the commit phase. This is something important because it will going to lead us to the next topic, which is effect. But right now we look at how can we now use the ref as a way to manipulate DOM elements, which is useful for most of the time to focus the input objects or to scrolling into a page, again, as a way to synchronize and to have now this way to remember things between re-render. Do not attempt to use ref for re-rendering because React doesn't keep track of that, and it makes your application harder to debug. So with that, then we look at how we can connect to external systems, which is one of the most extend. Yeah, this is one of the most extend and complicated, quote quote. But again, it's just covering as a specific use case. And at the end of the day, now the way of how you can interact with this external system to sync with external systems is by using effect. And we need to look at the distinction between effects and the events. So in React, we have two types of logic. You have is the rendering logic that must be pure, and you have now the event handler logic that can be is perform side effect, which is connect to a server. So when you are sending a data to a server, and when you do this, React teams create now this specific hook that allows us to run code, run side effect codes, or run that code that affects the system out of this function, where now it will run caused by rendering itself. All right? And the way how this code is run, or when this code is run, is by looking at the rendering mechanism. So React teams say, let's go to run now this piece of code after the commit phase. And understanding this specific mechanism with your own experience, especially using effect, is like minimize the use of effect, period. If you want to have a happy life, minimize the use effect for that. If you're not, if you can, well, write this self-contained effect into small testable areas. So, because now effects allows us to run this code or these side effects after every commit. We also need to look at we're also going to mention, which is something that we're going to also talk about, that is that you might not need to use an effect. So if you find yourself without needing to synchronize with an external assistant, to talk to an external assistant, you may not need an effect. So we look at how can we describe an effect by using the effect, and how the effects in there is actually running after every commit. Most of the time you don't want to do that. That's why we use the array of dependency as a way to say, hey, when this dependency change using the object.is, which is a built-in object from JavaScript, all right, now I want you to run this particular code. And because at the end of the day, using effects is to connect or to synchronize with external assistant, because we have a connect and disconnect, subscribe and unsubscribe. We also have this cleanup function, and from that I look at now the anatomy of the effect, which is you have the setup code, which is something that you pass initially, and inside of your setup code, you have is the cleanup code, which is passed through the return statement. So the second parameter here is the array of dependency, okay? And especially when you're working on development, how you can make your use effect to fix or to work with the development process, because now React 18 have these things called strict, which will re-render your components twice and recall your effect twice as a way to prevent any common gotchas and problems and issues that you might have in your hooks or in your rendering logic. So when you do this, especially if you have an effect in your components, it will go through the setup, cleanup, setup phase. So to understand, as I mentioned before, to understand that a little bit of this life cycle of what happened when you use your effect, which is now here, okay, is that it will now behave so it will now behave in this way. So when you mount this component, or when this component appears on the screen, it will now call this setup function first. And if you're in production, and if you're in development with the strict mode enabled, it will call your setup, cleanup, and setup function as a way to see is that everything works as expected. So if this component, once it is mounted, is now re-rendered, it will now call first a cleanup of code with the previous state, and then the setup code with the new state if the dependency change. Again, using the objet.is. And it will run now the cleanup code for one last time to when this component is unmounted. So understanding that, and when you're writing your effect, typically it fall into one of these patterns as they describe here. Like this, you know. So you will write. So most of the effects you will write will fit into one of the common patterns below, like this. So most of the effect you will write, so most of the effect that you will write will fit into one of the common patterns below, or is connecting to a React widget or controlling a React widget. So for example, a map, okay? You define your setup code using a ref, and the cleanup code as well, all right? So for ref, you might not need to actually clean up that, but if you're using a specific APIs, for example, like dialog, you will need to do that. The other is subscribing to events. So for example, window at event listener, okay? And then on your, and then on your cleanup function, you want to, well, remove that listener. Also is for triggering animations like that. Hey, I want you to, when you render these components, trigger the animation. Is that, hey, don't show that. Opacity is one, or show this element, the opacity one. And when you remove this element from that, you say, hey, I want you to now display, do not display this element, or to remove the opacity from that. So, and when it comes to actually fetching data, which is one of the 95% of things that you're gonna do with React, when you're writing your component using effect, is to fetching data, and how this is something that you need to actually is or ignore or abort. Again, this is the way of how now use effect is being used for that. So you define is your ignore followed by the logic inside of this. All right. Your async logic, where we can be you can use this now an async and await function here. They don't actually allow you to use this async here because this is not supported for the use effect right now. That's why they actually do is this kind of thing. Exactly. So the idea here is that by ignoring or aborting here, you're only going to get is the relevant data if you're actually fetching that data constantly, right? So with the ignore, what you're saying is that, hey, the previous state of this synchronization or calling this, I don't want to get that. I don't want that data. That data is stale. So now give me is this new data. So set this new data from that. And again, because this will render is after every commit when the dependency changes, in our case user ID. That's why when we are connecting to external systems, we put is the ignore flag, or we abort that operation. But usually we put is the ignore. So the idea here is that when we run this effect as caused by a dependency change, we want is to get now the new data and forget the old data. So that's why we have now is ignore flag followed by the async operations. And then on the cleanup method, hey, I want you to forget that data. I don't want that. I don't want that. Okay. So that's quite interesting. But even though, because like routing, fetching data is not a trivial, and using this particular approach is something that is very manual and can lead you to several problems. It's like your effects are not running in the server because it's running after every commit phase, as long as the dependency changes, or after the initial rendering. Your effect can also is perform network cascades or network waterfall, which is, so your parent component is now calling that. So your parent component is now calling that use of that effect, network request, as well as your child component can now perform is that network request, another network request, and so on and so forth, which makes is not ideal, okay, and slower your applications. Fetching directly in effect usually means that you don't preload or cache data. There is no way of how you can now preserve that data. It means that if you unmount and mount that component again, there is no way of how you can preserve that data right now, okay? And it's not very ergonomic because it's go with this race condition, that kind of thing. Yeah, because you go with this race condition. So because of this, okay, and the list is not specific to React. It applies to fetching data on mount with any library. So for example, Vue is another one, right? So like with routing, data fetching is not a trivial thing to do well. So they recommend is to say, hey, when you're going to handle this data fetching, which is 95% of the use case, okay? When you're going to do this, use a framework that has built-in solution for that, Remix, Gatsby, or Next.js. In our case, Next.js, okay? Or otherwise consider using is data fetching client side, right? So consider using or building your client-side catch. So for example, whether it is React Query or use SWR as a way to do that, and React Router here. So again, if you're going to build your own solution that is using effect underneath the hood, but add logic for deduplicate requests, catching response, and avoid network waterfall by preloading data or hosting data requirements to routes. So, but this is the thing that is been doing behind the scenes. It's like it's deduplicating requests, especially in development, deduplicating requests. Oh my God, it's very specific. Deduplicating requests, catching response, avoid network waterfalls. And this is again, it's not trivial this. And the other is sending analytics here. Again, when you're going to work with analytics, it is important to now set a flag for your analytics as a way to work with a staging environment, or you're developing a staging environment. So in your developing environment, you disable is analytics, so you don't want to pollute the database in production with that. So yeah, this is one of the things that you can do here. And then, well, we look at not an effect, initializing the application for that. Some logic should only run once where the application starts. You can put it outside of your components. When you need to initialize is only once, like this. Check out token, load data from local storage. Exactly. This guarantees that such logic only runs once after the browser load the page. And buying a product, in this case, when you want to buying is not caused by rendering, it's caused by specific interaction. It should run only when the user presses the button. Delete the effect and move your API buy request into the buy button event handler. This illustrates that if remounting breaks the logic of your application, this usually uncovers existing bugs. From a user perspective, visiting a page shouldn't be different from visiting it and clicking. And now we're looking at putting all together. But now, here we are you might not need an effect. So effects are a escape hatch from React paradigm. They let you step outside of React and synchronize your component with some external system like non-React widget, network, or browser DOM. If there is no external system involved, for example, if you want to update a component state when some props or state change, exactly. If there is no external system involved, for example, you want to update the component state when some props or state change, you shouldn't need an effect. Removing unnecessary effect will make your code easy to read, your code easy to follow, faster to run, and less error prone. Here is a why and how to remove unnecessary effect. Why and how to remove unnecessary effect from your component. How to catch expensive computation without effect. How to reset and adjust component state without effects. Okay, something that we can do. Okay, that's interesting. That's interesting. How to remove unnecessary effect and how to catch resetting all state when prop change. how to share logic between event handlers as well. It's like how to catch expensive computation, how to reset and adjust component state without effect, how to share logic between event handlers. How to share logic. How to share logic between event handlers. How to share logic between event handlers. Okay. Which logic should be moved to event handlers, and how to notify patterns component about change. Let's get into this. Why and how to remove unnecessary effect. Okay. Why and how to remove unnecessary effects from your components. How to catch expensive computation without effect. How to reset and adjust component state. Why and how to remove unnecessary effects. How to catch expensive computation without effects. How to reset and adjust component state without effect. How to share logic between event handlers. Which logic should be moved to an event handler? Which logic should be moved to an event handler? And how to notify pattern components about change. Okay. Let's get into it. How to remove unnecessary effect. There are two common cases in which you don't need an effect. You don't need effect to transform data for rendering. Okay. No. That's something that you can that's something that you can do in the rendering phase. Transform data for rendering. For example, let's say you want to filter a list before displaying it. You might feel tempted to write an effect that updates state variable when the list changes. However, this is inefficient. When your update state, React will first call your component function to calculate what should be on the screen. Exactly, what should be on the screen. Then React will commit this change to the DOM, updating the screen. Then React will run your effect. If your effect also immediately updates the state, this restarts the whole process from scratch. So to avoid unnecessary rendering phase, transform all of the data at the top level of your components. That code will automatically rerun whenever your props or state change. But this is if you want to transform data for rendering. Put that code at the top level, and anytime these components re-render based on a state updates, or whenever your props, whenever your props or a state change, that piece of code will run. Okay. That rendering code will run. Makes sense. Okay, or that rendering logic will run. But exactly. And now it's filling the gap here. It's filling the gap. Okay. This component will re-render when you set an state here, or this component will render is when you set an state here, when you use a context whose value state changed, or when it is props changed. When it is props, the context or the state change. Interesting. And here is describing that, and I truly understand this, because it's like you don't need an effect to transform data for renderings. Not at all, because if you do that, for example, React will now run that code. Okay, React will call the component, which is the rendering script, to calculate what it should be on the screen. So it will recreate the DOM, and then will commit this change to the DOM during the reconciliation phase, and using now Fiber, this reconciliation engine, to do that, updating the screen, and then run your React code. So if you now set a state in your effect, it will trigger the whole process again. So if you need to calculate or to transform data for rendering, this is the place that you would like to go. Totally. You don't need effects to handle user events. You don't need effects to handle user events. All right. Okay. Okay. So to handle. This is the two most common cases in which you don't need an effect. If you find yourself transforming data for rendering, you don't need an effect. If you need to, if you find yourself handling user events, you don't need an event. You don't need an effect. Okay, to handle user events like mouse, or using events like mouse over. So for example, let's say you want to send an API buy, post, request, and show a notification when the user buy a product. In the buy button, click event handler, you know exactly what happened. By the time an effect run, which is this code pass, you don't know what the user did, because all of those code already run. For example, which button was clicked. This is why you should usually handle user events in the corresponding event handlers. You do need an effect to synchronize, which is something that I mentioned here, to synchronize with external systems. For example, you can write an effect that keeps a jQuery widget, usually that, synchronized with React state. Again, in this code will be run is after every commit, as long as you set a dependency array for that. So you can also fetch data with effects. For example, you can synchronize the search result with the current search query. Keep in mind that modern frameworks provide more efficient built-in data. Built-in data fetching mechanism that writing effect directly in your component. To help you get the right intuition, let's look at some components concrete examples. But again, this is now the two common cases that you don't need an effect. When you need to transform data for rendering, or when you need to handle user events. So you do need effects to synchronize with externals. I do. Updating state based on props and state. Suppose you have a component with two state variables, first names and last name, and you want to calculate a full name. From them, by concatenating them, moreover, you'll likely full name to update whenever first name or last name change. Okay, so you are now having here is no. First, avoid redundant state and unnecessary effects. Perhaps this one. But now, if you can compute this information from props or from another state, great. In this case, because this is logic. Okay, but for some other cases, it's like you may need to actually understand how this actually works behind the scenes. Your instance may be add to full name state variable and update in an effect. Updating state based on props or state. Hell no. This is more complicated than necessary, and it is inefficient too. It doesn't an entire render pass with a state value for full name, then immediately re-render when the update values remove the state variable and effect in calculating that. Exactly. So this is when you need to calculate updating state based on props or state. If you find yourself transforming a data in rendering, you don't need an effect. When something can be calculated from existing props or state, don't put in a state, which is part of the way of how you can now organize your state structure. Avoid any redundant states. Choose a state structure. Avoid redundant state. Instead, calculate it during rendering. This makes your code faster. You avoid the extra cascading updates. Exactly. This code makes faster. You avoid the extra cascading updates. Simpler, you remove some code and less error prone. You avoid bugs using cause. You avoid bugs caused by different state variables get out of sync with each other. If this approach feels new to you, think in React and explain you should go into the state. No, but I'm quite familiar with. Catching expensive calculation. This component computes visible to-dos by taking the to-dos it received by props and filter them. Oh, how to remove unnecessary effect. Okay, updating the state based on props. In other words, if you can calculate this data, or you need to transform this data, you don't need an event, an effect. Catching expensive calculations. This component computes visible to-do by taking to-dos it received by props and filter them according to the filter props. Again, denial. If you can compute this exactly from its props, catching expensive computation. If you can compute that from its props, this is fine if get filters to is not slow. Exactly. If you can compute that, that's great. Like in the early example, this is both unnecessary and inefficient. First, this is both unnecessary and efficient because anytime this change, you're going to now set a new state update, which means that again, your one is at the end of the day, you just want is to set the visual state to do from that and show that data filter. So because of this, because this is so you are now here is redundance. You want to avoid and eliminate any redundant states and the unnecessary use effect. Okay, you just want is on every rendering is calculate that. So you say, hey, let's going to assign this to a variable and call this data as a way to filter it, as long as it is not too slow. Usually this code is fine, but maybe get filtered to is slow and you have a lot of to do. In that case, you don't want to recalculate that, okay? And only you want is to do that when the to do change. Or yeah, when the to do change. Or filters. In that case, you don't want to recalculate get filtering to do if someone related state variable like new to do has changed. You can catch or memorize an expensive calculation by wrapping it with useMemo. But this is now something, this is when things getting interesting, because here we are looking is that, hey, especially when you have control components, meaning components that depend or data that you, components that describe is importing information based on its props, okay? And then you don't want to actually, especially if you need to transform that data, and if you don't want to transform that data every time this component is rendering as caused by any of the parent components state updates, okay? As a way to now catch this computation, we use Memo for that. And only when this particular props change, I want you to return is this new thing. Holy moly, but the entire reason of this is that we are catching inside computation here between renderings. between re-renderings, and only apply them when it is necessary, or when those updates. So this is something interesting. This is something interesting. And this is something very, very, very interesting here. I am quite familiar with the Memo hook here. Okay, I'm very, very quite familiar with this hook. Totally. Okay. I am very quite familiar with this. Because here is a pattern. And the pattern is that if you want to catch computation between re-rendering, you can use Memo for that, and you're going to return this that, or use an arrow function for that. But again, is receive is a callback for that, a set of instruction to this. Hey, I want you to now, when these variables change, okay, I want you to now is run this function. That's beautiful. That is also high order function in practice. High order functions in practice. Yep, that's right. High order function in practice. So catching expensive calculations like this. This tells React that you don't want the inner function to rerun unless their dependency change. React will remember the return value of getFiltered to do during the initial render. During the next render, it will check if the to-do or filters are different using the object.is. If they are the same as the last time, useMemo will not return the last result it has stored. But if they are different, React will call inner function again and store it as a result. Behind the scenes is this closure thing. This nice little bonus feature that allows to write is, for example, memoization technique, or like once, all right? Or having the ability to keep track of where we are in a collections when we are iterating through all of these elements, all right? So for example, if you are now in a collection, and if you want to know the first element, and then the second element, and the third, the fourth, and you get the idea, how now the language keep track of this? Oh, because you're using it as a closure. Again, that's one of the reasons why you should focus is on one niche down here, and then you can expand. But that's exactly what we're doing. So niche down in here. React will remember the return value of getFiltering during the initial rendering. During the next render, it will check if to-do and filters are different. And it's exactly, if they are the same of the last time, useMemo, if they are the same of the last time, useMemo will return, exactly. If they are the same of the last time, useMemo will return the catch result, or the last result that is stored. If they are different, now React will render that, but it will now return is the last result it has a store. This function you using useMemo runs during rendering, so this only works for pure calculations. Keeping your components here. How to tell if a calculation is expensive? In general, unless you're creating or looping over 1,000 of objects, it's probably not expensive. If you want to get more confidence, you can add a console log to measure the time spent in piece of code. Console time and console time end. Perform the interaction you're measuring. For example, typing into the input, you will see logs like filter array 0.15 in millisecond in console. If the overall log times add up a significant amount, say 1 millisecond or more, it makes sense to memorize a calculation. As an experiment, you can then wrap the calculation in useMemo to verify whether the total log time has decreased for that iteration or not. And I'm going to use this as a way to show, and I'm going to use this as a way to show how can I improve that. Console.time and console.time end. That's great. Oh my God, what the hell wrong with this browser? What the hell wrong with this browser, man? Jesus. useMemo will make the first render faster. It only helps you to skip unnecessary work on update. Exactly. Meaning, again, this is, so instead of actually doing things faster, we are not doing things. You know, it's like, it's better. That's part of the React performance here. It's like, it is better to not doing things. It's better it's better to not doing stuff than doing it. It's much faster than not doing stuff than doing it. Keep in mind that your machine is probably faster than your users, so it is a good idea to test the performance with artificial slowdown. For example, Chrome offers a CPU throttling option for this. Also note that measuring performance in development will not give you the most accurate result. For example, when strict mode is on, you will see each component rendered twice rather than once. To get the most accurate timing, build your app for production and testing on a device like your user. Oh my God. Resetting all state when a prop changes. What you describe here is that how to tell if a calculation is expensive using the console time and time end. But this is from JavaScript. Never use this until right now. Resetting all state when a prop changed. The profile page component receives a user ID props. Resetting all state when prop changes. Okay. And the page, no, you can use here as a key for that. Resetting all state when a prop changes. This profile page component receives a user ID prop. The page contains a common input and you use as comment. Exactly, you use a comment. State variable to hold its value. One day you notice a problem. When you navigate from one profile to another, the comment state does not get reset. As a result, it is easy to accidentally post a comment on a wrong user profile. To fix this issue, you want to clear out the comment state variable whenever the user ID changes. So whenever the user ID changes, you're going to assign this as the key for that. So this is using this is an efficient. Not only that, because anytime that this is actually run, which is after every commit phase, you not only is running your so you not only is running or render these components, okay, with that particular state it is in there, and if you are setting the state or not, no problem. But also you are going to now run this. You're now run this. You're going to run this code to set up the state like that. So, in other words, you are adding more calculation to this, and you are complicating that. This is inefficient because profile page and its children will first render with the state value and then render again. It also complicates because you don't need to do this in every component that has some state inside of profile. For example, if the common UI is nested, you want to clear out the nested component in state 2. You want to actually clear is the entire subtree for that. Exactly. And to reset the entire subtree for that, now you use a key to that component. And when the user ID change, you want is to actually reset all the state, as long as the components are the same, in the same position of the render tree. Instead, you can tell React that each user profile is conceptually a different profile by giving it an explicit key. Split your components in two and pass a key attribute from the outer components to the inner one. Instead, you can tell React that each user profile is conceptually a different profile by giving an explicit key. So you say, hey, React, this user profile or this component page is different, is conceptually different profile by giving an explicit key. And because now React is store the state at the position of the render tree, you say, hey, I want you to now preserve this profile, or I want you to now make these components unique. Okay, make this component unique, and when the user ID change, reset that state. So normally React preserves the state when the same component is rendered in the same spot. By passing the user ID as a key to the profile components, you are asking React to treat two components or three profile components with different user ID as two different components that you should not share any state. You are telling that, hey, this component I want you to reset the state from this when this particular props change. Useful for profile from that. For example, you have a different user ID, you want to show is different data. So we to reset the state from that, because this is the way of how you can reset or preserve this state. Whenever the key which you set to user ID changes, React will recreate the DOM and reset the state. Exactly. Whenever the key which you are set up to user ID change, exactly. So whenever the user ID that is associated, or in this case, whatever value that is associated to the key change, React will recreate them and reset the state for that component. And all of it is children's. It's going to recreate is that component and all of it is sub-children's. Now the comment will fill with the reset state. So now the comment field will clear out automatically when navigating between profile. Note that this example, only the outer profile page component is exported. Only the profile page is exported and visible to other files in the project. Components rendering profile page don't need to pass the key to it. The pass user ID as a regular prop. The fact profile page passes as key to inner profile component is an implementation detail. But to tell React, hey, I want you to make this component and all of the sub-tree elements unique. And therefore, when this change, I want you to now recreate the DOM and reset the state. Adding some state when a prop change. Adjusting some states when a prop change. Sometimes you might want to reset or adjust part of the state on a prop change, but not all. The list component receives a list of items as props and maintains the select items in the selection state variable. You want to reset all the states or the selections to null whenever the item props receive. You want to reset the selection to null whenever an item props receive a different function, a different array. Again, you can use catch for that. Oh, resetting all state when a prop change. You can use catch for that. Better, adjust state while rendering. Adjusting some state when a prop change. So when this prop change, storing information from previous rendering like this can be hard to understand, but it's better than updating the same state in effect. In the above example, set selection is called directly during a render. React will re-render the list immediately after it exists with a return statement. React has not rendered the list children or updated the DOM yet, so this let the list children skip rendering the stale selection value. When you update a component during rendering, React throw away the return GSX and immediately retries rendering. React throw away the return GSX and immediately retry renderings. To avoid very slow cascade retries, React only lets you update the same component state during a render. If you update another component state during a render, you will see an error. A condition like items is different to previous item is necessary to avoid loops. You may adjust state like this, but any other side effects like changing DOM or setting timeouts should stay in the event handler or effect to keep component pure. Although this pattern is more efficient than an effect, most components shouldn't need it either. No matter how you do it, adjusting state based on props or other state makes your data flow more difficult to understand and debug. Always check whenever you call. You can reset all state with a key or calculating everything during rendering instead. For example, instead of storing and resetting the select item, you can store the select item ID. And then find them. And this is because you want to adjust that state for that. Best calculate everything during rendering. No, there is no need to adjust the state at all. If the item with the select ID is in the list, but this is adjusting some state when a prop change. If the item, if it's not, the selection calculated during rendering will be null because no matching item was found. This behavior is different but arguably better because most changes to item preserve the selection. So anytime you need to recompute this, okay, or catching expensive calculation, or you need to recompute that or adjust some state, to that, sharing logic between event handlers and sending a post change of computations, initializing the application. Okay. All right. Okay. All right. Okay. Well, I think that'll be all for this video. Take care. Bye bye.